In the second demo, I'd like to use a DHT humidity and temperature sensor and a photoresistor. I'd like to be able to use my browser and get readings from the sensor formatted in HTML and in comma separated values that our computers find easier to read. The two sketches that correspond to these two scenarios are almost identical. The only difference is that one outputs HTML while the other one outputs text as comma separated values. What you're going to need is the Arduino Ethernet shield, a DHT sensor, a photoresistor, and a 10 kilo ohm resistor to be used as voltage divider. In this demo, I'd like to use my DHT22 sensor and a photoresistor to take measurements from the environment and then report those measurements to a web client that requests them. And I'm going to do this in two different ways. The first way, the client is going to be a human using the web browser. So we're going to have a formatted HTML page sent back to the user. In the second example or variation of the same sketch, we'll be reporting for a machine. A machine doesn't care about nicely formatted web pages, it wants efficiency. So instead of HTML, I'll be sending back just text with the values delimited by a comma. It's comma separated values or CSV format. First I'll show you the scripts and what they do, and then go through them and see how they do it. So here's a first example. This one creates a HTML page, sends it back to the user nicely formatted. So I'll upload it. So while that is happening, a quick look at the hardware. I've got the Ethernet shield attached to my Arduino, and on the breadboard a DHT sensor and a photoresistor through a resistor. So it's a voltage divider. So the photoresistor reports its value to analog pin 0, and then the yellow wire, it's the data wire for the DHT sensor, reports values to digital pin 2. Okay, so let's have a look now. We've got the sketch uploaded. The server is running at this address. So I'm going to copy that and paste it in here. And here is my report. There's a value 834 in analog pin 0. Humidity is 39% and temperature currently is 31%. And that refreshes every 5 seconds. To do the same thing, but now for a machine instead of a human, I'll be using this script, a small variation. Let's upload it. And refresh the page. Now you see that instead of getting a nicely formatted HTML output, I get comma delimited values. So these are the values separated by a comma. Machines find it really easy to parse this kind of data. So imagine that you've got perhaps another program somewhere that perhaps is logging data in order to chart them. You could get that program to poll your Arduino and ask for current values every few seconds or few minutes or hours. It really depends on the application, and all that comes back is this comma, a set of values delimited by a comma. So let's have a look at how this happens. I'm going to put the two scripts one next to the other so that we can compare. All right. Now, most of the two scripts are identical. It's a merge of the web server script that we saw in the previous demo and the script from section 2 where we introduced the DHT sensors. So you can see, for example, here that we are including the DHT library and we are setting the data pin where the DHT sensor is sending its data to digital pin 2. The rest is pretty much the same. We're defining the type of the DHT sensor here, declaring a handle to it. So the DHT variable is going to be pointing to the DHT object. All these things are familiar. Now we're setting up the server just like we did in the first demo in this lecture. We are passing the GET request just like we did earlier. So here's the block where we have detected, or where we detect the end of the GET request, so then we can construct our response. The first part of the response, again, it's identical to what we saw in demo 1. Then the differences begin. So we're going to take a reading from analog pin 0 where the photoresistor is connected. It's exactly the same thing that is happening in the CSV version of the sketch. We also take, and then we just print it out using HTML. So we've got the HTML document starting here, and we just print out a little bit of text as a label, and here we print out the reading from analog sensor 2, analog sensor in analog pin 2. On the CSV side, we don't open up an HTML document using an open HTML tag. We just go straight away and we print out the sensor reading, and then we print out a comma to delimit the sensor reading from the next reading that is going to come up. Another little difference that I forget to mention is the content type. So for the CSV version, the content type is text/text, whereas at for the HTML version it was text/HTML. Continuing with the sketch, you'll see that we take humidity and temperature readings from the DHT device exactly the same way in both scripts. And then for the HTML version, we construct the HTML document, so we use the tags to format the document, whereas in the CSV version, we don't. We just print out the value and insert a comma in between these values. That's about it. The rest is exactly the same. So the lesson to take home from this is that depending on who is requesting the data, you need to provide appropriate formatting. Usually that's HTML for humans and something like comma separated values or JSON format for machines, and that way you can construct yourself a really simple reporting web service. You covered a lot of ground in this lecture. You learned about how HTTP requests are structured and how the Arduino can host a very simple reporting server. There were a lot of details involved, but what I think would be most useful to remember is the fact that a web server is essentially a parser of text which interprets HTTP requests and responds. Although the examples in this lecture did not do much parsing other than figuring out where a HTTP request ends so that a response can be sent, what you learn will prove very useful in the next lecture. In that lecture, you will learn about creating a server that parses a request so that it can find out the specific parameters of what it is that is being requested to do. You will learn, for example, how to get the server, which is running on the Arduino, to turn on the LED at pin 9. I call this kind of server controlling because it allows you to control the Arduino via the web, not just to get readings of its status. As an exercise, try to add a couple of sensors of your choice to the HTML version of the Demo2 sketch. Adjust the sketch so that the values are printed nicely to the client. If you have CSS skills, perhaps improve the looks of the output by incorporating some styling to the page that the Arduino generates.